So hello everyone, welcome. This is lecture number 9 of analytical geometry where we are seeing straight lines, lecture number 3, right? So in the previous classes we have completed direction cosines, direction ratios, planes, right? And in the last two classes we are studying about straight lines, and this class is very important in UPSC point of view, right? So we're going to study about coplanar lines and the shortest distance between two lines. So these two concepts are very important for UPSC point of view. So if they are deciding to ask a question in straight line, 70% they will ask only from this topic, that is coplanar lines and shortest distance between two lines. So this lecture is very important in straight line point of view. So first, what we're going to do in this lecture is we're going to introduce coplanar lines, right? So you know already we know coplanar. They give two coplanar means nothing but it is intersect, right? So two lines will intersect. What is the condition that two lines will intersect? Right? What is the condition that the two lines will intersect? That is what we're going to see first. After that, what is the condition that the two lines intersect? After that, we will introduce more concept on coplanar lines, right? Everything is clear, right? Video is clear, right? Okay, so first what we'll do is we will define what is meant by coplanar line, and then we will highlight all the condition for coplanar lines. Okay, so in this lecture we're going to consider two topics: coplanar lines and shortest distance between two lines, right? Okay. First, coplanar lines. So first, what you're going to do is to find condition. So to find a condition, so to find the condition, the two lines whose equations are given, whose equations, whose equations are given, whose equations are given may intersect. May intersect, right? Intersect nothing but they are coplanar, right? That is they are coplanar. And equation of plane, and to find the equation of plane, and to find the equation of plane in which they lie. Right? This is what the first topic is about, right? See, they will give two straight lines, right? To find the condition that two lines whose equations are given may intersect. See, very simple. They will give two lines, right? They will give two lines. What is the condition that these two lines will intersect? It need not intersect all the time, right? Given two lines, it need not be intersect all the time, right? For example, if you consider these two lines, it will never intersect, right? So what is the condition that the two lines will intersect? you always make sure that both the lines are in symmetrical form, right? Because if we convert that to symmetrical form, everything will be very easy to calculate. They will give two lines that can be in symmetrical form or it can be in general form also. So you know how to convert general form to symmetrical form, right? You always make sure that whenever you are doing problems based on coplanar line, make sure that both the lines are in symmetrical form, right? So let us say first what we're going to do is we're going to find what is the condition that this will intersect. Okay, right? So let us take two lines. Let us take the first line to be x minus x1 divided by a1. So I'm writing in symmetrical form. Y minus y1 divided by b1. Z minus z1 divided by c1. So instead of alpha, beta, gamma, I'm writing x1, y1, z1. Right? Okay. So what is this? This is the equation of this line L1 in symmetrical form, right? What is A1, B1, C1? A1, B1, C1 is the direction ratio of L1 and X1, Y1, Z1 is the known point, fixed point in the line L1. And let us consider L2, another line X minus X2 divided by A2, Y minus Y2 divided by B2, Z minus Z2 divided by C2. So here X2, Y2, Z2 is any point on the line L2 and and A2, B2, C2 is the direction ratio of L2, right? So we'll talk about Q lines later, right? Ankita, please. Okay. Now we have L1, L2, right? Now the condition that the two lines will intersect is the condition that two lines, the given two lines will intersect is given by determinant of x2 minus x1, y2 minus y1, z2 minus z1, right? So determinant of x2 minus x1, y2 minus z, a1, b1, c1, a2, b2, c2 is equal to 0, right? This is the condition that the two lines intersect. See, x2 minus x1, y2 minus y1, z2 minus z1 all will be a number. A1, B1, C1, A2, B2, C2 again all will be number here. Expand this determinant. If this is equal to 0, then it will intersect. How to find the point of intersection? How to find the point of intersection? So to find point of intersection, very easy, right? That is we have said that it intersect. Let's say this is Q, right? Q is the intersection point. These two lines will intersect if this happens. Now to find point of intersection, to find point of intersection, so to find the point of intersection, let us say the first line is equal to R, second line to be equal to some S, right? Let us equate that. So we have L1. What is L1? It is x minus x1 divided by A1, y minus y1 divided by B1, z minus z1 divided by C1. Let us say it is equal to some R, right? So that means any point on the coordinate will be of the form what? So any point on this line will be of the form. So what is x? RA1 plus x1. What is y? RB1 plus y1. What is z? RC1 plus z1. So any point on the line L1 will be of this form. Now what is L2? So any point is of the form is of this form. Now similarly, what is the second line L2? It is x minus x2 divided by A2, y minus y2 divided by B2, z minus z2 divided by C2 is equal to R. So here any point will be of the form RA2 plus x2, RB2 plus y2, RC2 plus z2, right? You just solve for x, y, z here. Equate everything to be equal. Okay, let us say it is equal to some S. because we already used R. Let us say this is equal to S. Right, SC2 plus Z2. Now we need to get the point of intersection, right? That means both the coordinate has to be same. Yes or no? Both the coordinate has to be same for some R and S. For some R and S. So equate, solve 1 and 2. Now solve 1 and 2. So this is any point will be of this form. This any point will be of this form in L2. Now solve 1 and 2. This you just equate RA1 plus X1, comma RB1 plus Y1, R RC1 plus Z1, RC1 plus Z1 is equal to SA2 plus X2, SB2 plus Y2, SC2 plus Z2. Right, now equate and solve for R and S. Right, we just solve for R and S, equate the terms and solve for RS. You will get the value of R and S, which you can easily substitute back here to get the point of intersection. Right, now to find the equation of plane which they lie, see what we are going to do. To find the condition that the two lines whose equations are given may intersect, this is the condition, and we also find the point of intersection. And to find the equation of plane in which they lie, now what we are going to do is we have said that the two lines intersect, right? Two lines intersect. This is the condition. Now we are going to find the equation of plane in which these two lines lie. We are going to find the equation of plane in which the two lines lie, right? So this is, we have a line L1, we have a line L2, right? And we know X1, Y1, Z1 is the known point, and we know X2, Y2, Z2 is the known point in L2, and this has direction ratio A1, B1, C1, and this has direction ratio A2, B2, C2, right? So we know this. Now we're going to find the equation of plane in which they lie. This is what we're going to write. And to find the equation of plane, to find equation of plane, so to find equation of plane which they lie, which they lie means which the two lines lie, which the two lines lie. So that equation of plane is given by, see, you can take x1 y1 z1 or x2 y2 z2, anything. So I'm taking x1 y1 z1. So x minus x1, y minus y1, z minus z1, and direction ratio of first line, direction ratio of second line is equal to 0. So if you expand this, you will get the equation of plane, or you can also use x minus x2, y minus y2, z minus z2, a1, b1, c1, a2, b2, c2. So you will get the equation of plane in which they lie. So you can either take x1, y1, z1, a1, b1, c1, a2, b2, c2 is the direction ratio of L1 and L2. So you expand this determinant, you will get the equation of plane. That's it. See, that's it, right? If you understand these two slides, then you can do any problem. Always make sure that the given two lines are in symmetrical form, right? If they give in general form, means convert that to symmetrical form, which we already know how to do, and do the procedure like this, right? The coplanar is nothing but what is the condition that the two lines intersect. This is the condition the two lines intersect. To find the point of intersection, you equate this to R, equate this to S, solve for R and S. That's it. Now to find the plane in which they lie, you just make use of this formula. You can either take x1 y1 z1 or x2 y2 z2, right? Okay. So now we'll move on to problems. Just a minute. Then what is problem number 1? Prove that the lines x minus 1 divided by 2 is equal to y minus 2 divided by 3 is equal to z minus 3 divided by 4, and x minus 2 divided by 3, y minus 3 divided by 4, z minus 4 by 5 are coplanar. See, if they are, both the lines are in symmetrical form, right? If um, if one is in, if both are in general form, that has separate procedure. But I'm not doing that. Even if both are in general form, you convert that to symmetrical form and follow the same procedure for symmetrical form, right? I'll tell you when that problem comes. So first here it is very easy. Both are in symmetrical form only. So we need to show that they are coplanar. So what is the condition? So what is x1? What is x1, y1, z1? It is 2, 1, 2, and 3, right? See, you make sure that it is in symmetrical form. X minus x1 by a, y minus y1 by b. It has to be in that form, right? If it is minus y or something, you need to alter slightly. So x1, y1, z1 is 1, 2, and 3. x2, y2, z2 is 2, 3, and 4. And what about direction ratio of the first line? It is 2, 3, 4. And direction ratio of the second line, A2, B2, C2, is 3, 4, 5. So we need to expand the determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2. So expand this determinant. So determinant of x2 minus x1. So 2 minus 1, 3 minus 2, 1, 4 minus 3, 1, a1, b1, c1, a2, b2, c2. So 1 into 15 minus 16, 10 minus 12, 8 minus 9. So minus 1 plus 2 minus 1, so which is 0. So therefore they are coplanar. They haven't asked us to find the point of intersection, and they haven't asked us to find in which the plane they lie. So just they have to ask us to show they are coplanar, so which we have did very easily. So we'll move on to second problem. So problem 2, show that the lines intersect. Show that the lines x plus 1 divided by minus 3, y minus 3 by 2, z plus 2 by 1, and x by 1 is equal to y minus 7 divided by minus 3, z plus 7 divided by no, intersect. And find point of intersection and also equation of plane containing them. And also the equation of plane containing them. Okay. So first we need to show that they are intersect and coplanar both are same only. So you just write this in symmetrical form. So what is x1 y1 z1? So x1 y1 z1. See, here it has to be minus, right? So it will be minus 1, 3 and minus 2. So symmetrical form is x minus x1. So but you have plus here. So minus of minus 1. And x2 y2 z2, x2 y2 z2 will be 0 7, 0 7 and minus 7. And a1 b1 c1 is given by minus 3 to 1, and the a2 b2 c2 is given by 1 minus 3 2. So find x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. So expand this determinant. So 0 minus of minus 1, 7 minus 3 is 4, minus 7 plus 2 is minus 5, minus 3 2 1, 1 minus 3 and 2. So 1 into 4 plus 3, minus 6 minus 1, minus 5 into 9 minus 2. So 12 is will be minus 7, it will be plus 28. 9 minus 2 is 7. 5, 4 plus 3 is 7, minus 4, minus 6 minus 1, minus 7 minus plus 28. Sorry, minus. So 4 plus 3 is 7, it will be plus 28. 9 minus 2 is 7, it will be minus 35, so which is 0. So therefore they are coplanar. That is they will intersect. They will intersect. Right? So all these are very easy only. So now to find the point of intersection, to find point of intersection, now to find the point of intersection, equate the first line to R, second line to S, solve for R and S. Solve for R and S. So x plus 1, x plus 1 divided by minus 3, y minus 3 by 2 is equal to z plus 2 by 1. Let us say it is equal to some R. So what about x? X is minus 3r minus 1, y is 2r plus 3, z is r minus 2. And similarly, what is L2? So L2 is x by 1, y minus 7 divided by minus 3, z plus 7 by 2. Z plus 7 by 2, let us say it is equal to some s. So here x is s comma minus 3s plus 7, 2s minus 7, right? Now to find point of intersection, these two coordinate has to be same. So I'm just equating this. So minus 3r minus 1, 2r plus 3, r minus 2 is equal to s comma minus 3s plus 7, 2s minus 7, right? Just have to solve this. So, so we have minus 3r minus 1 is equal to s. This is the first equation. So we take that side, s plus 3r is equal to minus 1. And similarly, if we equate second term, we have 2r plus 3 is equal to minus 3s plus 7. So if we take that side, we will have 3s plus 2r is equal to 4, right? So 3s plus 2r is equal to 7 minus 3, 4. Now solve for r and s. So multiply this equation by 3. So this will be 3s. This will be 9r. This will be minus 3. And let us subtract this minus minus minus. This will get cancelled. So 9r minus 2r is 7r. Minus 3 minus 4 is minus 7. So we have r to be equal to minus n. You don't need to solve for s, right? You don't solve for s, just substitute r to be here. If you are solving for s, substitute here. If solving for r, substitute here. So substitute, let us call this as 1, call this as 2. Substitute r is equal to minus 1 in 1. So minus 3 times minus 1 minus 1. 2r plus 3 r minus 2. So plus 3, 3 minus 1 is 2. Minus 2 plus 3 is 1. It will be minus 3. This is the point of intersection. Right, so 2 comma 1 comma minus 3 is the point of intersection. Now to find equation of plane in which they lie, right, in which these two lines lie. So you know the formula. So it is nothing but x minus x1, y minus y1, z minus z1, a1 b1 c1, a2 b2 c2, c equal to 0. So x1 y1 z1 we already know, minus 1 3 minus 2. A1 b1 c1 minus 3 2 1, 1 minus 3 2. You just expand this, you will get the answer, right? Just expand this, you'll get the answer. It will be x plus y plus z is equal to 0. This is the equation of plane in which they lie. Is it clear? You just have to expand x plus 1 into this minus of y minus 3 into this z plus 2 into this. You will get the required answer. Is it clear? Okay. Now we'll move on to see. I have done only one problem in this type. You can do any problem now, right? If they change the equation means the procedure is same only. The only thing is x1 y1 z1, x2 y2 z2, a1 b1 c1, a2 b2 c2. That is the one that is going to change, right? So I'm not going to do more problems in the same type. It will take time. If they give two lines in symmetrical form, and if they ask you to show that it will intersect, find point of intersection, and to find the equation of plane in which they lie, you need to follow this procedure. That's it. You can do any problem. So we move on to problem number 3. In problem 3, what we're going to have is, instead of two lines in symmetrical form, one will be in symmetrical form, other will be in general form. Right? So in problem here, two lines are in symmetrical form. Now in problem 3, we're going to have one in symmetrical form, the other in general form. Problem 3. Show that the lines, show that the lines x minus 4 is equal to y plus 1 by 2 is equal to z, and 4x minus y plus 5z minus 7 equal to 0, that is equal to 2x minus 5y minus z minus 3r coplanar. Find the equation of plane and find point of intersection and plane containing them. The same problem. So instead of two lines in symmetrical form, here we have one in symmetrical form, the other in general form. See, there is separate method for this, but don't follow that. You convert this to symmetrical form. That's it. You know how to convert general form to symmetrical form, right? You make it is don't study so much of methods, right? This is one of the easiest method. If you know two lines symmetrical form, you know the condition for intersection. You know how to find the point of intersection, and you know equation of plane which containing them. So try to bring every concept to this idea, right? So what we're going to do is first we will convert this. They have given this in general form, right? So first what we'll do is before getting into problem, we will convert this general form to symmetrical form. Then you will have two lines in symmetrical form. Follow this previous procedure. That's it. Okay. So we will we will convert 4x minus y plus 5z minus 7 is equal to 0 is equal to 2x minus 5y minus z minus 3 in symmetrical form. Right? So very easy. What is this? This is nothing but, so we have two planes. This is the equation of line, right? This is the equation of line. We know how to convert, right? The previous class itself, we have mentioned how to convert uh, general form to symmetrical form. This is the required line, right? Let us say this has direction ratio a comma b comma c, right? So to find the equation of any symmetrical form, what we should know? We should know direction ratio, and we should know any one point, any one coordinate on the line, right? They are given two planes, P1 and P2. And first we will find, we need to know two things, right? One is direction ratio of this line, the other is any coordinate. We already know the procedure. See, they have given what is the direction ratio of normal to this plane. What is the direction ratio of P1? Is 4 minus 1, 5. 4 minus 1, 5. What is the direction ratio for normal for P2? 2 minus 5 minus 1. 2 minus 5 minus 1. And we know this L lies in P1 as well as in P2. This normal is perpendicular to the plane. That means it will be perpendicular to this line also. So therefore, the corresponding direction ratio will satisfy A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So A1, A2, B1, B2 plus C1, C2 is 0. So we have to find it to find the direction ratio. To find direction ratio, so we have 4A minus B plus 5C is equal to 0. 2A minus 5B, 2A minus 5B minus C is equal to 0. Now solve for ABC. So we have A divided by B divided by C divided by. So we have minus 1, 5, minus 1, 5, 4 minus 1, minus 5, minus 5 minus 1, 2 minus 5. So 1 plus 25, 10 plus 4, 10 plus 4 minus 20 plus 2, right? 1 plus 25, 10 plus 4, 20 minus 20 plus 2. Okay, so that means A comma B comma C will be of the form 26, 14 minus 18, right? You can also take two outside also. Direction ratio only, right? There are many direction ratio. One direction ratio is enough, and we know it is proportionals only, right? So you can either take two common here. You can keep that as 13, 7 minus 9. This direction ratio only, right? You can take any direction ratio on the line, only proportional only. If I divide by 2, we will have 13 7 minus 9. So this is the direction ratio of L. Now to find any one point, what you have to do? You can either put x is equal to 0 and solve for yz, or you put y is equal to 0 and solve for xz, or you put z is equal to 0 and solve for xy, right? So uh, let us take x to be equal to 0, right? Put x is equal to 0 and solve for xy and solve for x and y. See, actually, actually, you don't need to actually see, very simple. We know x2 minus x1. Okay, let us do like this. Solve for x and solve for y and z. See, if x is 0, we have minus y plus 5z is equal to 7. Let us call this as equation number 1. And here when x is 0, we have minus 5y minus y minus z is equal to 3, right? So let us multiply 5 here. Let us multiply 5. So this will be 5y, this will be 25z, this will be 35. Now you need to multiply by minus, this will be plus, this will be plus, this will be minus. So we have 5y minus 5y plus 5 will get cancelled. 25z plus z, 26z is equal to 35 minus 3 is 32. So z is 32 by 26. 2 16s are 2 13s are. So z is 16 by 13. Z is 16 by 13. Okay, so we will go with this. I mean, z is 0. I mean, when z is 16 by 13, 5z is equal to 7 plus y, right? So 5 into z is equal to 7 plus y. So y is 5 into 16 by 13 minus 7 will be 580. 80 minus 91 divided by 13. So minus 11 by 13. So one of the point is when x is 0, y is minus 11 by 13, z is 16 by 13. This is one of the point, right? That is 2 16s are 2 13s are 50, 80, 80 minus 70, 91. Yes. So therefore, the equation of line L2 is given by x minus 0 by y plus 11 by 13 z minus 16 by 13 divided by, so direction ratio A1 B1 C1 13 7 minus 9, right? And we know L, this is L2 and we know L1 also, right? So therefore we know both the lines symmetrical form. Then you can follow the same procedure. Then you can follow the same procedure. We need to show they are coplanar and equation of plane containing them. So we have two lines. So L1 is already given, x minus 4 by 1 is equal to y plus 1 by 2, y plus 1 by 2 z, and L2 is, just now we have found x by 13 is equal to y plus 11 by 13 divided by 7, z minus 16 by 13 divided by minus 9, right? So we have x1, y1, z1 to be 4 comma minus 1 comma 0. This is z minus 0 divided by 0. See, dividing by 0 does not mean that it is infinity. So here it is giving the direction ratio, right? Okay. See, if you feel it is very lengthy, I'll tell you one more procedure to do this kind of problem when one is in general form, other in symmetrical form. First, I'll tell you the easiest way, that will take time. Then after doing this, I will let you know in one more method also. One in general form, other in symmetrical form, right? Okay. So we have L2. So what is x2, y2, z2? So x2, y2, z2 is 0, minus 11 by 13, 16 by 13, and we have a1, b1, c1 to be 1, 2, 0, a2, b2, c2 is equal to, sorry, z minus, sorry, it is 1. Right now for to find the condition of coplanar, so you need to expand determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2. So this will be determinant of x2 minus x1. It will be minus 4, minus 11 by 13 plus 1, 16 by 13, a1, b1, c1, a2, b2, c2, right? So 13 minus 11 is 12. So this will be 2 by 13. So minus 4 into minus 18 minus 7. This will be 13 minus 11 is 2 by 13. So we'll have minus 2 by 13 into minus 9 minus 13 plus 16 by 13 into 7 minus 26. So this will be minus 25. Minus 25 into minus 4 is plus 100. And here we will have minus 2 by 13 into minus 22, and here we will have 16 by 13 into minus 19, right? So we'll have 100 plus 44 by 13, 100 plus 44 by 13 minus, what is 16 into 19? 16 into 19. So 9 6 are 54, 9 1s are 9, 4 1 6 6 10 3 not 6, right? 16 into 9 9 9 9. think I made some mistake. Yeah, I'm not getting 0. See, is everything correct here? Two, 1, 13, 7 minus 9 x 2. X minus 4, y plus. Okay, okay. The question is minus 2. Question is minus 2, sorry. Okay, it not going to affect L, it's L1, right? Minus 2, sorry. X minus 4, y plus 1 by minus 2, z, 4x minus y plus 5z minus 7, 2x minus 5y minus z minus 3. Yes, sorry, the question is minus 2 here. Okay. Now we will expand, we'll see what happens. This will be minus 4 into 18 minus 7. This will be 13 minus 11 is 2 by 13. So 2 by 13, you will have minus, okay, 13 minus 11 is 2 by 13, right? So we'll have minus 2 by 13, minus 9, minus 13, right? Plus 16 by 13 into 7 plus 26. So 18 minus 7 is 11. This will be minus 44, and this will be minus 2 by 13 into minus 22 plus 16 by 13 into 26 plus 7 is 34. Right? So we will have minus 44 plus 44 by 13 plus 16 by 13 into 34. So this will be 44 into 13. 3 fours are 12. 3 fours are 12. 32. 44, 44, 2, 2, 7. Will be minus 572 plus 44 divided by 13. What is 16? 34 into 16. 4s are 24. 6 3s are 18. 3 20, 34. So 4, 4, 5. 544. Two. Sorry, 7 plus 26, 33. Sorry. See, we are making some mistake. I think you do this problem. Uh, you just do this right. I think we have made some minus or plus mistake anywhere. So just do this problem, we'll get zero, right? Because we are doing it is coplanar. It is a long procedure, right? Very thing easy only. We are just converting this to symmetrical form, and already that it is symmetrical form. Apply the condition. That's it, right? So 13 7 minus 9. I think you are making mistakes somewhere. But the procedure, everyone understand procedure, right? So you'll get zero here when you simplify this. Okay. So 44 into 13. What is 44 into 13? 440. 24 into 3 is 132. This 570 minus 574. So we just do this problem, right? So take an exercise. You get zero, right? Okay. Now I'll tell you the other method to show that they are coplanar. So here what we are doing is here what we are doing is we are converting this general form to symmetrical form, right? Here we are converting this general form to symmetrical form. After that, we are having two lines in symmetrical form. Then we are doing the previous procedure, right? Now what we'll do is instead of converting this to symmetrical form, we will show they are coplanar, right? We will show they are coplanar, and they will not ask you to find the point of if they ask you to find point of intersection means surely you have to convert that to symmetrical form only. But majority of the cases, if they give one in symmetrical form, other in general form, they will ask you to show they are coplanar and find the plane containing them. They will not ask you to find the point of intersection. To find point of intersection, if they ask you to find point of intersection, and if they give you one in symmetrical form, one in general form, you have to convert this general form to symmetrical form to find point of intersection. But in majority of the cases, I have included this to find point of intersection. But in question, there won't be point of intersection. Show that they are coplanar and find the plane containing them, right? So how to do? Here what we are doing is we are converting this general form to symmetrical form, and then we are doing, right? So instead of this, we can do the other procedure also, right? So I'll give you the alligator. See, I'll just write down some story. You just see whether you are following or not, right? So we need to show they are coplanar. uh, okay. See, the same question only, right? Okay. Alligator. They have given two lines, right? The first line is in symmetrical form. X minus 4 is equal to minus 1 by 2 into y plus 1 is equal to z, and second line is 4x minus y plus 5z minus 7 is equal to 2x minus 5y minus z minus 3. Now we need to show, now what we need to show, they are coplanar. Now equation of plane they lie, right? They will not ask you to find point of intersection majority of the cases. I have just included, just I have just rephrased the question to find the point of intersection. But in an exam point of view, if they give one in general, one in symmetrical form, means that 99% they won't ask to find point of intersection. In that case, you can go for this method. You can go for any method which is best for you. But I'll tell you the one more method also, right? One is in general form, other is symmetrical form. Okay. Now we need to find the equation of plane in which the two lines lie, and we need to show that they are coplanar also. See, L1, see what is L2? So L2 is this line, right? So L2 is this line. L2 is this line, and let us say L1 is this line, right? Let's say this L1 is this line, and L2 is this line. So we have P1 and we have P2. Now you can clearly see any plane through second line, right? I'm going to write down story, but it's very easy to follow. So any plane through L2 is given by, what is the equation of plane through L2? You already know, right? What is the equation of plane passing through the line of intersection? It is P1 plus lambda P2 is equal to 0, right? So equation of plane through L2. So equation of plane through L2 we already know. So equation of plane through L2 is P1 plus lambda P2 is equal to 0. This we already know, right? So what is P1? It is 4x minus y plus 5z minus 7 plus lambda times P2 2x minus 5y minus z minus 3 is equal to 0. So we have 4 plus 2 lambda into x minus 1 minus 5 lambda into y 5 minus lambda into z 5 minus lambda into z minus 7 minus 3 lambda is equal to 0. This is the equation of plane. This is the equation of plane right now. Is it clear up to now? First, see, I'm just telling you the later how to show they are coplanar and to find equation of the plane that containing the line. We I will always recommend to do follow this procedure. It is very easy only, right? It involves some calculation, but it is very easy to understand and visualize. Now this will take some if there are some difficulty to do this. Okay, so first we are finding any plane through L2 is of the form P1 plus lambda P2 is equal to 0, right? Okay. Now uh, it will be parallel to L2, right? So it will be parallel. Yeah, write down something. You just understand this, right? First, write it down. If it is if it is parallel, if it is parallel to the line L1, right? Then we have instead of this, it is parallel. See, I think this will be lengthy. I think. See, whether you understand this procedure or not, see, this is whether you understand this procedure or not. So you know how to do this, right? You just convert the general form to symmetrical form and do the thing, right? See, this will involve so much of confusion here if I go by this method, right? We don't need this method. You just whether you understand this method or not, show that the line and we are given two line, one in general form, other in uh, yes. So you just go for this method only, right? So don't need for any method to convert this to symmetrical form and follow the previous procedure, right? Yes. So I think I've made some plus or minus mistake anywhere, so that only we haven't got 0 here. If I do by this correctly, you'll get 0 here, right? Everything is same as previous only. Only thing is, um, yes, you just go for the previous one, right? Don't confuse yourself. Very easy only. Don't get uh, too confused, right? Very easy only. Actually, these are right. You just have to convert this to symmetrical form and follow the previous procedure. That's it, right? So I think you will just check out where we have made mistake in this problem. so that we will have some satisfaction when we move into second problem, fourth problem. So they are given first line 1 minus 2 1 4 minus 1 0. So we know x1 y1 z1 a1 b1 c1. We are converting this to symmetrical form. So we are finding direction ratios. So it is minus 1 5 minus 1 5 4 minus 1 minus 5 minus 1 2 minus 5. So 1 plus 25 10 plus 4 minus 20 plus 2. Yes. So 26, 14 minus 18. So after this is correct, right? 13, 2 13s are, 2 7s are, 2 9s are. So 13, 7 minus 9 is the direction ratio of this line. So to find any one coordinate, we are putting x is 0 and we are solving for y and z. We are solving for y and z. So what I'm doing is I'm putting x is equal to 0 and solving for y z. So when x is 0, we have minus y plus 5z is 7 minus 5y minus z is equal to 3. Right? Okay. So after this is correct. So I'll check the question once again. 4x 4x minus y plus 5z minus 7 2x minus 5y minus z minus 3. Okay. Now we'll solve for y and z. So if I multiply this by 5, 25, 35. So we need to change sign now. So this will be plus plus minus. This will be 25 plus 1 is 26 is it? 35 minus 3 is 32. So we have z is equal to 32 by 26. So 2 16s are 2 13s are. That is 16 by 13. And from here we have 5 z is 7 plus 5. So z is 16 by 13. So y will be 5 into 16 by 13 minus 7. 5 tens are 50, 5 6 are 30. So we'll have 80. 80 minus 91 divided by 13. So minus 11 by 13. This is also correct. So x1, y1, z1, this is one of the coordinates. So x minus 0, y minus 11 by 13, z minus 16 by 13. Direction ratios are 13, 7, minus 9. Okay. 13, 7, minus 9. Here we have y plus 11 by 13, z, yes. So x1, y1, z1 is 4 minus 1, 0. x2, y2, z2 is 0 minus 11 by 13, 16 by 13. a1, b1, c1 is 1 minus 2, 1. a2, b2, c2 is 13, 7 minus 9. Okay. Now x2 minus x1 is 0 minus 4 minus 11 by 13 plus 1. 16 by 13 minus 0. Yes. 1 minus 2, 1. 13, 7 minus 9. So 13 minus 11 is 2 by 13. This will be 16 by 13. So minus 4 into 18 minus 7. Yes. Here you have plus 2 by 13. So we'll have minus 2 by 13 minus 9 minus 13. 16 by 13 7 plus 26. Yes. So 18 minus 7 is 11. 11 into minus 4 is minus 44. So we'll have minus 2 by 13 minus 9 minus 13 will be minus 22. 16 by 13, 26 plus 1 will be 33. So we will have minus 44 plus 44 by 13 plus 16 by 33, 13 into 33. Now 13 into 44 is 572. So we will have minus 572 plus 44. Minus 572 plus 44 is minus 528. 16 into 33. Yes, I think I got the answer only. Correct only, right? I think I got the answer. I think here we have made some mistake. So if I do in calculator, we are getting the right answer. So both are minus 528 and plus 528. This will be 528 by 13. So you will get minus 528 by 13 plus 528 by 13. Not only, right? Okay, so that we have shown that they are coplanar. So therefore, now you need to find equation of plane containing them, right? So equation of plane containing them. So it is given by x minus x1, y minus y1, z minus z1, a1, b1, c1, a2, b2, c2 is equal to 0. So here what is our x1, y1, z1? x1, y1, z1 is 4 minus 1, 0. Right? 4 minus 1, 0. 4 minus 1, 0. A1, b1, c1, a1 minus 2, 1. 1 minus 2, 1. 13, 7 minus 9. Now this expand this, you will get the equation of plane which they contain. You can also find the point of intersection by just equating this, right? Yes, yes, it was correct. Okay. So now next problem will be, see, in this first two problem, both the line symmetrical form, right? So here you can see both in symmetrical form. In problem 2, both in symmetrical form, we need to show they are coplanar. We need to find point of intersection, and we need to find the equation of plane containing them. Very easy. Now in this problem, one is general form, other is symmetrical form. We have converted this general form to symmetrical form and follow the previous procedure. Now we are going to have both the lines in general form. You can do this, right? Both the lines in general form. Right? Both the lines in general form. So problem number 4. I think I don't want to do, right? You just have to convert both the general form to symmetrical form, and then you need to follow the previous procedure. Okay. So I think you can take this exercise problem, right? So I'll just give you the hint. So both the lines are in general form, right? Both the lines are in general form. So we're going to convert both will be in symmetrical form, right? So convert both in symmetrical form. You can do this, right? You can do this easily. So I'll just write down the answer. See, if you convert this to symmetrical form, you will have, see, symmetrical form need not be unique, right? If you put x is equal to 0 and solve for y z, you will have one symmetrical form. If other person put y is equal to 0 and solve for x z, they will have some other symmetrical form, right? So the symmetrical form for L1 is given by x minus 4 by 1, y plus 1 divided by minus 2. Z, they are here, they have see, they have put z is equal to 0 here. They have put z is equal to 0 and they have solved for xy to get minus 4 and minus 1 as the answer, right? Sorry, 4 and minus 1. Now similarly, if you convert this second general form to symmetrical form, you will have x1 minus 11 by 7 divided by 13, y1 minus 0 divided by 7, z minus 1 by 7 divided by minus 9. So here you can see they have put y term to be 0, right? Here they have put y term to be 0. From now on, you can easily show they are coplanar and find the plane they are intersecting, right? You can do this, right? You just have to convert the general form to symmetrical form, which we already know. So you just have to solve for direction ratio of C. They are given two. This is the this is our L1, right? Similarly, they are given L2 also. L2 also, right? So you know P1, P2, and you know P3, P4. So P1, P2, P3, P4. And this has some direction ratio. This has direction ratio 1, 1, 1. And this has direction ratio 2, 3, 4. Now let us say this is the required line. Let us say this direction ratio is a comma b comma c. Now a plus b plus c is 0 and 2a plus 3b plus 4c is 0. Solve for abc, you will have 1 minus 2 1. Now to find any point, you just take z is equal to 0. If z is 0, this will be 0, this will be 0. Now solve for xy, you will get 4 and minus 1. So you will get L1. Now similarly for L2 also, you convert to symmetrical form and do the problem, right? So can you move on to next problem? So this is one set of problem that we have discussed, which is they will give two line. You need to show they will intersect, find the point of intersection, find the plane. So three things we have learned, right? Now if both are in symmetrical form, very easy. If one is general form, other is symmetrical form, you convert the general form to symmetrical form. If both are in general form, convert both to symmetrical form and follow the previous procedures. Is it clear, right? Yes. So we will have a 2 minutes break. We're going to do two more problems based on this. After that, we'll be moving on to the next concept, shortest distance between the lines, right? So we'll have a 2 minutes break. I think this session is going to be very long because I thought of finishing this everything by 45 minutes, but it has gone up to 1.5 hours. Okay. So we'll start the second problem number 5. So prove that the lines, they have given two lines. You need to show they are coplanar and find the equation of plane they lie. Both are in symmetrical form only, right? Very easy only. So you just write L1. So x minus, you should have minus. So you will have a minus b divided by alpha minus delta y minus a divided by alpha z minus a plus d divided by alpha plus delta. Alpha minus delta, alpha plus delta. Alpha minus delta, alpha plus delta. Yes, we have another line L2. Take minus outside, we will have b minus c divided by beta minus gamma y minus b by beta. Right, so we know x1, y1, z1, we know x2, y2, z2, and we know a1, b1, c1, a2, b2, c2. So the condition for coplanar is has to be 0, right? x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2. This determinant has to be 0. So x2 minus x1. So x1, x2. So b minus c minus a plus d, b minus a, b plus c minus a minus d, right? x2 minus x1. So x2 is b plus c, x1 is a plus d. This is alpha minus delta, alpha plus delta, beta minus gamma, beta plus gamma. So we have this is equal to determinant of a b c d. So we have a minus d, b minus d, right? Okay. So what we can do is let us add. Okay, see, if I add this column and this column, this delta will get cancelled. So we will have 2 alpha. And if I add delta, you just have to expand this. Expand this, need to show it is equal to 0. But I'm trying to use some row column operation. If I try to bring any two rows identical or any two columns identical or one column is a multiple of other, determinant will be 0. That means the property. Right, so before expanding this, let us try to do some operation. So I'm just going to add these two columns. So column 1 is equal to column 1 plus column 3. If I add these two columns, if I add these two columns, minus c plus c will get cancelled, bd will get cancelled. So b plus b is 2b, we will have 2b minus 2a, right? 2b minus 2a, this is what we will have if I add these two columns. Minus c plus c will get cancelled, b minus b will get cancelled, so we will have minus a, b plus b, so we will have 2b minus 2a. Alpha minus delta, alpha plus delta, delta will get cancelled, so we will have 2 alpha, right? And if I add this, we will have beta. Instead of writing 2b minus 2a, let us write this as 2 times b minus a. 2 times b minus a, right? If I add this and this, let us keep other as it is. B minus a, alpha, beta, b minus c minus a minus d, alpha plus delta, beta plus gamma. So you can see it is equal to 0, right? Because you can see column 1 is twice 2 times c1 is identical to c2. So if you know that two columns are multiple of other, they are linearly dependent. So therefore their determinant will be 0. So therefore they are coplanar, right? See, these two are linearly dependent. See, if you have seen linear algebra, these two vectors are linearly dependent vectors. So therefore determinant will always be 0 if you have linearly dependent vectors, right? Okay. So therefore, they are coplanar. Now to find equation of plane which they lie. So instead of expanding whole, just try to make some row column operations. So that try to bring some properties of determinants. Now to find equation of plane containing them. So equation of plane in which they lie. So we know it is x minus x1, y minus y1, z minus z1, a1, b1, c1, a2, b2, c2 to be 0. So x1, y1, z1 we already know. So just try to substitute here. So x1 is a minus d, y1 is b, y1 is a, z minus z1 which is a plus d, a1, b1, c1, a2, b2, c2. So alpha minus delta, alpha, alpha plus delta, alpha plus delta, beta minus gamma, beta, beta plus gamma is equal to 0. Just expand this, right? Just expand this and get the required answer. You will get a plane. Okay. See, here also to expand this, we can use some row column operations. Again, do the same column operation. C1 is equal to C1 plus C3. So if we do this, we will have, what about this? X minus A plus D plus column 3. Z minus A minus D. These two will get cancelled. So we will have x plus z minus 2a. X plus z minus 2a. Column 1 plus delta delta will get cancelled. So we will have 2 alpha. Gamma gamma will get cancelled. So we will have 2 beta. So we will have x plus z minus 2a. Let us keep this as it is. Y minus a alpha beta z minus a minus d alpha plus delta beta plus gamma. Now here we have, okay, let us multiply 2 here to this column. Let us subtract these two. See, if you are expanding determinant, if some terms are 0, it is very easy to calculate, right? So what we will do is, let us multiply 2 to this column and subtract this with first column. So C1 is equal to C1 minus 2C2, right? So if I do this, C1 minus 2 times C2. So already C1 is x plus z minus 2a minus 2 times C2. So C2 is y minus a. So we will have x plus z minus 2a minus 2y plus 2a. So we will have x minus 2y plus z, right? X minus y, sorry, x minus 2y plus z. X minus 2y plus z. Now what about these terms? This will be 0, right? So 2 alpha minus 2 alpha, 2 beta minus 2 beta. Let us keep these terms as it is. Now expand this, you will have only this term into this minus this, right? So if you expand this, you will have x minus 2y plus z into alpha into beta plus gamma minus beta into alpha plus delta is equal to 0, right? Alpha into beta plus delta is equal to 0. See, that's it. um this number into this number gives you 0, right? We need to find equation of plane. That means this implies x minus 2y plus z is 0, right? Alpha beta gamma need not be 0 0 0, right? All this term will not be 0. Therefore x plus z minus 2y has to be 0. This is the equation of plane, right? Is it clear? It's a very easy problem, number 5. Okay. So now what we will do is we'll move on to the next concept, shortest distance between. See, for coplanar line, we cannot talk about shortest distance. Yes or no? For coplanar line, we cannot talk about shortest distance. Coplanar line means they will intersect. So obviously, shortest distance will be zero. Yes or no? For coplanar line, they will intersect. So obviously, the shortest distance will be zero between the line. For non-coplanar, that means they are called skew lines. Right? They are called skew lines. Right? If they do not intersect me, they are called skew lines. Now for skew lines, uh, we will be finding the shortest distance between the two lines, right? So whenever they give two lines and they ask us to find the shortest distance, it has to be skew lines only. If it is coplanar means obviously they will intersect, and obviously the shortest distance will always be zero, because at zero both are intersecting, right? Shortest distance will be zero only. So we will very easy problem, right? Very easy problem. Very important exam point of view, right? So you can expect a question from shortest distance. You can expect from coplanar or from this concept, right? Very important concept. Okay. Okay. The shortest distance between two lines are said to be skew lines. Okay. So we'll introduce the concept first. Just a minute. Yes. The next concept is to obtain the shortest distance. See, you just have to remember two formulas. That's it. For the previous concept, you need to remember two formulas, right? This also two formulas only. What are those two formulas in the previous concept? One is the condition for coplanar: x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. Determinant has to be zero. And the equation of plane which they lie: x minus x1, y minus y1, z minus z1, a1 b1 c1, a2 b2 c2 is equal to zero. Similarly, here are also two formulas, right? Okay. So to find the shortest distance between two given lines, between two given lines, between two given lines, and to obtain and to obtain and to obtain the equation of this shortest distance. See, very important exam point of view. Very simple, right? I'm just going to give you two formulas. One formula is shortest distance. Uh, the other is find the equation of shortest distance, right? Okay. So first, uh, we will introduce one definition. What is the definition of skew line, right? Two lines are kept to be skew lines. Two lines, two lines are said to be skew lines. Skew lines or non-intersecting line, or non-intersecting lines if they do not lie in the same plane. If they do not lie in the same plane, right? And the straight line and the straight line, the straight line which is perpendicular, straight line which is perpendicular to which is perpendicular to this non-intersecting line, to this two non-intersecting line, two non-intersecting line is called the line of is called the line of shortest distance. The length of this line is called the line of shortest distance. The length of this line intercepted between the given lines, is called the length of the shortest distance. Very easy to follow, right? Very easy to follow, right? From the very easy to understand, right? So two lines are said to be skew lines if it is non-intersecting and they do not lie in the same plane, and the straight line which is perpendicular to this non-intersecting line is called the line of shortest distance, and length of this line is called very simple. So we have two lines, right? So we have L1 and we have L2. They will not intersect, right? They will not intersect. If it is intersecting means they will be coplanar. Shortest distance will be 0 always, right? Okay. So L1 and L2. Actually, in exam point of view, if they give two lines and ask you to find the shortest distance means first you need to check for whether they are coplanar or not. If it is coplanar means you directly blindly put it is 0. If it is not coplanar only, you need to follow this procedure. But in exam point of view, they will say find the shortest distance between the plane means 100% it will be not coplanar only, right? Okay. So L1, L2, right? So they will give two lines. We need to find, see, two lines are said to be skew lines that we know. If they do not pass the same, the straight line which is perpendicular to this non-intersecting line. So a straight line which is perpendicular to these two lines is called the line of shortest distance, right? This is the line of shortest distance, and this distance is called, we're going to find the equation of this line as well as shortest distance. That's it. So to obtain the shortest distance between the two given plane and to obtain the equation of the shortest distance, this is a line only. So we're going to find the equation of this line as well as the distance between the shortest distance between these two lines. Shortest distance between the two lines is always nothing but you just draw a line that is perpendicular to L1 and L2, right? And find the distance. I'm just going to give you the formula for shortest distance and equation of shortest distance. Then you can do any problem based on this, right? Okay. Now, so we have two lines, right? We have two lines L1. So x minus x1 divided by a1, y minus y1 divided by b1, z minus z1 divided by c1. And we have one more line L2, x minus L2. See, let us say PQ is the line of shortest distance, right? So let PQ, okay, first write it down. A2 y minus y2 divided by B2 z minus z2 divided by C2, right? So we have two lines x1 y1 z1 is one of the um, x1 y1 z1 is one of the point in L1, x2 y2 z2 is one of the point in L2. A1 b1 c1 is direction ratio of first line, a2 b2 c2 is the direction ratio of the second line. So let PQ be the line of shortest distance. See, refer diagram, right? So let PQ be the line of shortest distance, right? So whenever I'll write SD, this shortest distance, right? Okay. Now we need to find the distance of PQ that will give you the shortest distance formula. So that distance is given by, so the distance of PQ is given by, I'm going to write on the formula. So that formula is given by L into x2 minus x1, yes, L into x2 minus x1, m into y2 minus y1, n into z2 minus z1. That's it, right? Just have to remember this formula, right? Now what is x, you know x1 y1 z1, x2 y2 z2. What is LMN? Where where L comma M comma N is the direction cosine of PQ, right? You just have to find direction cosine. See, to find shortest distance, they will give you two lines. You can easily find x1 y1 z1, x2 y2 z2 from the given line itself. Only thing is you need to find direction cosine of the line PQ. That I tell you the procedure how to find. Very easy only. After finding LMN, substitute in this formula, you will get the shortest distance between the two lines. Right? Now to find the equation of this shortest distance, there are two methods. One we can find in symmetrical form, and we can also find in general form. See, equation of this, we need to find equation of PQ. In exam point of view, they will ask you to find the equation of PQ. Either it can be symmetrical form or in symmetrical form. If they simply say find the equation of the shortest distance, means you go for symmetrical form because that is very easy to find. But if they ask you to find the equation of PQ in general form, you need to follow some method, right? So to find the equation of PQ, to find equation of PQ, I'll let you know in problem, right? You can do by, you can you can find in symmetrical form, you can find in symmetrical form, right? Or you can find in general form. There are two separate methods to find that I will let you know in one problem. If you understand one problem, you can do any problem. So you can find in general form. I'll let you know how to find in general form and symmetrical form, right? Okay, so we will start the first problem. Is it clear up to now? Is it clear up to now? The shortest distance formula is L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. LMN is the direction cosine. Remember, in this direction cosine, not direction ratio. LMN is the direction cosine of PQ. And to find equation of PQ, you can find a symmetrical form, symmetrical general form that we will let you know, right? That I will let you know. Okay, so we will do the first problem. One problem is enough to do any problem. Just a minute. Just a minute. So problem number one is show that the shortest distance show that the shortest distance, show that the shortest distance, just a minute. Okay, show that the shortest distance between the straight line between the straight line. So they are given two line x minus 3 by 3, y minus 8 by minus 1, z minus 3 by 1, and x plus 3 by minus 3. The printing is not clear in this book. That is the only. X minus 3 by 3, y minus 3 by minus 1, z minus 3 by 1, and x plus 3 divided by minus 3, y plus 7 divided by 2, z minus 6 by 4 is 3 root 30. Find also the equation of equation of line of shortest distance. See, if you understand this single problem, you can do any problem, right? If you understand the single problem, you can do any problem, right? So first what we'll do is we need to show that this is uh, see, all these are previous year's question. I'm not writing any year. Actually, these are previous year's questions. Okay. See, we have they given two lines and they ask you to show the shortest distance. Obviously, it will be non-coplanar. You can check it out. So see, we have two lines, right? So we have two line L1 and we have the line L2, and we know a line that is perpendicular to PQ is the shortest distance, right? Okay. Now what is the formula for shortest distance? We already know. Okay. Now what is L1? L1 they have given, right? Okay. Now what is direction ratio of this L1? Direction ratio of this L1 is 3 minus 1 1. 3 minus 1 1. And what is the direction ratio of L2? It is minus 3 to 4. Right? See, make sure that it is symmetrical form. X minus 3 by 3, y minus 8 by minus 1, z minus 3 by 1. And one of the point is 383, right? One of the point is 3 comma 8 comma 3. Again, one of the point is minus 3 minus 7. See, whenever you have, just make a diagram, then you'll have more clarity, right? This is what they have given. Now we need to find PQ, right? So, okay, I'm not going to write both the lines. Let modulus of PQ, right, be the shortest distance. Be the shortest distance. Be the shortest distance. What is the formula? It is given by L into x2 minus x1. Shortest distance is given by L into x2 minus x1, m into y2 minus y1, n into z2 minus z1, right? Okay. Now, what is LMN? Where LMN is the direction cosine of PQ. So before that, what is x1 y1 x1 y1 z1, x2 y2 z2? We already know, right? This is our x1 y1 z1. This is our x2 y2 z2. So what about x2 minus x1, y2 minus y1, z2 minus z1? So minus 3 minus 3 m into y2 minus y1 minus 7 minus 8 z2 minus z1 6 minus 3. So shortest distance will be given by minus 7l minus 15m plus 3n. This is the shortest distance. Let us call this as A. Now what is where L comma M comma N is the direction cosine of PQ, right? Now let us say this has direction ratio A comma B comma C, right? Let us assume that first we will find direction ratio. After that um, we will talk about direction cosine, right? Now you can see PQ is perpendicular to L1 as well as it is L2, right? The line PQ is perpendicular to L1. The line PQ is perpendicular to L1. The corresponding direction ratio will satisfy A1 A2 plus B1 B2 plus C1 C2, right? Okay, minus 6 here. So what is the direction ratio of PQ? It is A comma B comma C. And what is direction ratio of L1? Direction ratio of L1 is 3 minus 1 1. 3 minus 1 1. So therefore A1 A2 plus B1 B2 plus C1 C2 is 0. So we have 3A minus B plus C is 0. Call this as equation number 1. And similarly, the line PQ is perpendicular to L2 also. Right, L2 also. What is direction ratio of PQ? It is A comma B comma C. And what is direction ratio of L2? Direction ratio of L2 is minus 3 to 4. Minus 3 to 4. They are perpendicular. So we will have minus 3A plus 2B plus 4C is equal to 0. See, this is the method to find direction cosine of PQ. First, you find direction ratio of PQ by using the condition that L1 is perpendicular to, PQ is perpendicular to L1 as well as PQ is perpendicular to L2. So that means ABC is a direction ratio of PQ. You know direction ratio of these lines. Just make use of A1 A2 plus B1 B2 plus C1 C2 is 0. Now solve for 1 2. Now solve for 1 and 2. So we have minus 1 minus 1 1 3 minus 1 2 4 2 4 minus 3 2. A, this is B, this is C. We have A divided by B divided by C divided by minus 4 minus 2 minus 3 minus 12 6 minus 3, right? So we have found the direction ratio, right? Direction ratio is generated by minus 6 minus 15 3 minus 6 minus 15 3. See, this is same as if you divide by 3 minus 2 minus 5 1. So minus 2 minus, you just divide by direction ratio only, right? You can be proportionals also. So let us divide by 3. So we'll have minus 2 minus 5 1. So we have found direction ratio. So we know direction ratio of PQ. So direction ratio of PQ is minus 2 comma minus 5 comma 1. What about direction cosine? Just have to normalize this, right? So it is minus 2 divided by root of 4 plus 25 plus 1 minus 5 divided by again root of, this will be root 30, right? 1 divided by root 30. So therefore minus 2 by root 30 minus 5 by root 30 1 by root 30 is the direction cosine of PQ. So we have found L comma M comma N. So therefore the shortest distance be given by from A, we know shortest distance is minus 6L minus 15M plus 3 times N. This is shortest distance. So minus 6 times L is minus 2 by root 30 minus 15 times M is minus 5 by root 30 plus 3 into N 1 by root 30. So this will be 12 plus 3, 12 plus 3 plus 15 pies are 25 divided by root 30. So 90 divided by root 30. I can write 3 into 30 by root 30. I can write 30 as root 30 into root 30 divided by root 30. So 3 root 30 is the shortest distance between the given line. That is what we need to prove, right? So the shortest distance is 3 times root 30. Is it clear up to now? So can you able to find? Can you find any? You can do any, right? So if they give two lines symmetrical form, you can easily find shortest distance between them using the formula L into x2 minus x1 m into y2 minus y1 plus n into z2 minus z1, right? Okay. Now, see, to understand this single problem, you can find shortest distance between any point. Suppose if they give one in symmetrical form, other in general form, you convert the general form to symmetrical form, make use of the same procedure. You know how to find shortest distance between two symmetrical lines. Equation of line can be in symmetrical form or in general form. If both are in general form, convert both to symmetrical form and follow the same procedure. So you just have to remember one formula, which is L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1 is equal to 0, right? Okay. So this is the procedure to find shortest distance. Now to find PQ, symmetrical form is very easy to find. Yes or no? Because to find the equation of line PQ, if you want to find the equation of this line in symmetrical form, you should know any one point. You should know direction ratio. That is enough to find the equation of line PQ. Direction ratio we know, right? What is direction ratio? We already found direction ratio of a comma b comma c, which is minus 2 comma minus 5 comma 1. Now we should know any one point on this line, right? Now what is P point? What is the point P? That we don't know, right? That is, I'm trying to find the equation of line PQ in symmetric. What we're going to do is we're going to find the equation of line PQ. I'm going to tell you both the method. I'm going to find the equation of line PQ in general form as well as in symmetrical form, right? Now how to find in symmetrical form and how to find in general form. So first I'll tell you how to find in general form, right? How to find in general form. General form, we should have two planes, right? We should have two planes, right? Okay. So first we will find equation of PQ in general form. To find equation of PQ in general form. Very simple. Just listen this slide, right? Just listen this slide. So what I'm going to do is, what you need to do is just a minute. Yes. Now for general form, you should have two planes combined, right? That means you need to find two equation of plane. Okay. Now what I'm going to do is, equation of plane. What I'm going to do is, first I'm going to find equation of plane passing through PQ, and L1. I'm going to find this equation, right? Equation of plane passing through PQ and L1, right? I'm going to find the equation of plane passing through PQ and L1, right? Okay. Then I'm going to find an equation of plane that has to pass through PQ as well as L1. Now, how to find equation of plane passing through PQ and L1? And similarly, you need to find equation of plane See, for diagram, it is hard to draw that. Equation of plane passing through PQ and L2. This is what we need to find. So you will have here one plane, combine that, you will get the general form. So you need to find equation of plane passing through PQ and L1, PQ and L2. Right? That will give you in general form. Okay. See, very hard to draw this here. So we need to find an equation of plane that has to pass through. See, what is general form diagram will be? What is general form diagram will be? So we will have, this is the PQ, right? So we will have some plane here. We will have some more plane here. This is the equation of plane in general form. We are finding this plane and this plane. Now, how we are finding this plane is equation of plane passing through PQ and L1. Equation of plane passing through PQ and L2. This will give you general form. This is what we are doing there. So how to find equation of plane passing through L1, passing through L2? That is equation of plane passing through two lines. Yes or no? Equation of plane passing through two lines. Both are line only. PQ is line, L1 is line. Equation of plane passing through again two line. So how to do that is very simple. How to do is very simple. See, what is L1? What is L1? X minus 3 by 3, x minus 3 by 3, y minus 8 by minus 1, z minus 3 by 1. This is the line L. We don't know PQ, right? But we know direction ratio of PQ, right? We don't know, but we know the direction ratio of PQ, which is 2, 5, 1. See, I'm going to give you one formula. How to find the equation of plane if one is in symmetrical form, the other, that is equation of plane passing through two lines. One line is in symmetrical form. For other line, you know only direction ratio. That it is given by, equation of plane is given by x minus x1, y minus y1, z minus z1, a1, b1, c1, a2, b2, c2 is equal to 0. Just a minute. Here x1, y1, z1 is a point on L1. A1, B1, C1 is the direction ratio of L1. A2, B2, C2 is the direction ratio of, yes, it's the direction ratio of PQ. That's it. Right? Or we will write like this, L1 and PQ. So for PQ, you know only direction ratio. You know L1 in symmetrical form. How to find the equation of plane? We already know this plane, right? We already know this equation of plane, but here the only thing is x1, y1, z1 is this point. A1, B1, C1 is the direction ratio. A2, B2, C2 is the direction ratio of PQ. Is it clear? Equation of plane passing through two lines. It has condition. One line is symmetrical form. For other line, you know only direction ratio. That equation of plane is given by this, right? So therefore, this will be x minus x1, y minus y1, z minus z1, 3 minus 1, 1. What is direction ratio of PQ? 2, 5 minus 1. Right? So therefore, expand this, you will get, 4x minus 5y plus 19z minus 83 is equal to 0. Now, similarly, you find equation of plane passing through PQ and L2. So, what is L2? L2 is x plus 3 divided by minus 3, y plus 7 divided by 2, z minus 6 by 4. What is the equation of this plane? X minus x1, y minus y1, z minus z1. So, it will be x plus 3, y plus 7, z minus z1, minus 3, 2, 4, direction ratio of PQ, 2, 5, minus 1. See, you just have to understand this this line. So the same equation of plane, but here the only thing is x1, y1, z1, you take that from line. A1, b1, c1 is take that from direction ratio of line. A2, b2, c2 is direction ratio of PQ, right? So expand this, you will have 22x minus 5y plus 19z minus 83z. Sorry, here it is 4x minus 5y minus 17z plus 79 is equal to 0. So, what is the general form? So, therefore, equation of PQ. Just have to combine this. This is the equation of PQ. So, can you from now on you can find any, right? So, to find the equation of plane passing through two lines, one line is symmetrical form. For other line, you know only direction ratio, right? So L, so you can see that arrow mark. L1 is symmetrical form, PQ only direction ratio. So L x minus x1, y1, z1, dr of PQ. So we will do one problem and then we will wind up this session. So the second question is, see, I'm going to find, we will do one more problem and then we will wind up this session, right? Is it, oh, okay, we need to find this in symmetrical form, right? Okay, we have found equation of plane in a general form. I have said we can also find the equation of plane in symmetrical form also. Okay, let us try to do out. Let us have a 1 minute break. So I think we don't need to find a symmetrical form, right? If you know general form, you can convert that to symmetrical form, right? So always find equation of plane in general form, right? That is easy. If they ask you to find equation of plane in symmetrical form, you convert this general form to symmetrical form, right? We don't need any separate method for that. Again, it will take time. So if they ask you to find the, see, they will only say find the equation of line PQ. They will not say find in general form or symmetrical form. But you always find in general form using this method. Suppose in extreme case, if they ask you to find PQ in symmetrical form, you convert this general form to symmetrical form, which you already know, right? Okay. We'll move on to second problem. This page is very important, right? This is the equation. How to find equation of plane passing through two line. One line is in symmetrical form, other you know only direction ratio. Apply this formula, right? Okay. So problem 2, find the shortest distance between, find the shortest distance between z axis and the line x plus y plus z. Very simple. You know direction, you know the equation of z axis, and you convert this general form to symmetrical form and apply the, just a minute. I think the battery is down. Okay, so find shortest distance between z axis and the line. So you know what is z? What is the equation of z axis? What is the see? L1 is z axis, right? What is the equation of z axis? It is x minus 0 by 0, y minus 0 by 0, z minus 0 by 1, right? So it passes through. See, z axis nothing but. So what is the equation of line passing through a point and direction ratio? So direction ratio of z axis is 0, 0, 1, and it passes through the point 0, 0, 0. So symmetrical form we can easily write. Now what is L2? L2 is in general form. We will convert that to symmetrical form first, right? L2 is in general form. We will convert that to symmetrical form. We will convert this to symmetrical form and then we will apply the shortest distance formula. Okay. So they have given two planes. This is the line L2. This is the line L2. Let us say this as a direction ratio A comma B comma C, right? And this as direction ratio 1 1 1, and this plane 2 as direction ratio of normal C comma 1 comma 2. So we have A plus B plus C is equal to 0. 3A plus B plus 2C is equal to 0. Now solve for this, you will get the value of direction ratio of ABC, sorry, direction ratio of L2. So we will have A divided by B divided by C divided by, so 1 1 1 1 1 2 3 1. So 1 minus 2, 3 minus 2, 1 minus 3. Therefore, the direction ratio of A comma B comma C is minus 1 1 minus 2, right? Minus 1 1 minus 2. So we need to find any one coordinate, right? Let us put x is equal to 0 and solve for y z. So to find one coordinate on L2, let us put x is equal to 0 and solve for y z. If x is 0, we have y plus z is equal to minus 3. And if x is 0, here we have y plus 2z is equal to minus 2. Let us minus plus. So z minus 2 is minus z. Minus 3 plus 2 is minus 1. We have z is 1. If z is 1, we know y plus z is minus 3. So y plus 1 is minus 3. So y is minus 3 minus 1. So y is minus 4. Right? So one of the coordinate is, one coordinate on L2 is x is 0, y is minus 4, z is 1. So 0 comma minus 4 comma 1. So minus 4 plus 1 is minus 3. Minus 4 plus 2 is minus 2. Right? So what is equation of L2? So L2 is x minus 0, y plus 4, z minus 1 divided by, what is direction ratio? Minus 1 1 minus 2. Minus 1 1 minus 2, right? Minus 1 1 minus 2. So we know both the line in symmetrical form. Just apply the distance formula, sorry, shortest distance formula. So we know L1 and L2. So L1 is z axis. So it is x minus 0 by 0, y minus 0 by 0, z minus 0 by 1. See, remember, we are dividing by 0 doesn't mean that it is infinity. Here 0 denotes the direction ratios, right? Direction ratios. That only, right? 2, oh, sorry. It's 2 minus 1. Sorry, it is 2 minus 1. So it is plus 1. 1 1 minus 2 is the direction ratio. 3 minus. So 1 1 minus 2 is the direction ratio, right? Plus 1. Okay. And what about L2? So L2 is x minus 0 by 1, y plus 4 by 1, z minus 1 by minus 2, right? So 1, 1 minus 2 is the direction ratio of, thank you, of L2. So you know x1, y1, z1. The shortest distance is L into x2 minus x1, m into y2 minus y1, n into z2 minus z1. Just now only we are starting the problem. We are converted both in symmetrical form. Now only we are going to start the problem. So L into x2 minus x1, y2 minus y1. So y2 is minus 4, minus y1 is 0, z2 is 1, is 0. So shortest distance is minus 4m plus n is the shortest distance, right? So we have a line L1, we have a line L2, and we need to find shortest distance PQ. Let us say this has a direction ratio a comma b comma c, but we need to find direction cosine of what is this L comma m comma n, where L comma m comma n is direction cosine of the shortest distance line PQ. Now we know this PQ is perpendicular to L1 and PQ is perpendicular to L2 also. So PQ is perpendicular to L1. So what is the direction ratio of PQ? The assumption is a comma b comma c, and L1 direction ratio is 0, 0, 1. They are perpendicular. That means we have C is equal to 0, right? A1, A2 plus B1, B2 plus C1, C2 is 0. And similarly, PQ is perpendicular to L2 also. So this has direction ratio a comma b comma c, and the line 2 has direction ratio 1 comma 1 comma minus 2. So again they are perpendicular. So a plus b minus 2c is equal to 0. Now solve this and this. Right? Now solve this and this. Solving. So we know c is 0. So if c is 0, a will be minus b, right? And we know c is 0. So we have a is equal to minus b. So the direction ratio is a is minus b, c is 0. So that means one of the direction ratio is minus 1, 1, 0. So if we take b outside, it is proportional to b, right? Okay. So what about direction cosine? It is minus 1 by root 2, 1 by root 2, 0 by root 2. This is the direction cosine. L comma m comma n. The shortest distance is given by minus 4m plus n, right? Minus 4m plus n. So minus 4 times m is 1 by root 2, n is 0. So minus 4 by root 2. Let's put modulus here. So that we will have 4 by root 2. Let's write 4 as distance, right? You don't need to put negative. So this root 2, I can write root 2 into root 2 divided by root 2. So 2 root 2 is the shortest distance between the lines. Is it clear? 2 root 2 is the shortest distance. They haven't asked you to find the equation of line PQ. Even if they also, you can find that in general form using the previous concepts, right? That is, you find the equation of line passing through PQ and L1, equation of plane passing through PQ and L1, equation of plane passing through PQ and L2, x minus x1, y minus y1, z minus z1, a1, b1, c1, a2, b2, c2, x1, y1, z1 is 0, 0, 0, 0, 0, a1, b1, c1 is 0, 0, 1, a2, b2, c2 is the direction ratio of PQ, which is minus 1, 1, 0. You will get equation of plane P1. And similarly, find equation of plane passing through PQ and L2. Do you want to find that? So okay, let us find that, right? Okay, let us find the equation of line PQ so that you will have more clarity. Here they haven't asked you to find equation of line, but you will find equation of line PQ. Equation of line PQ in general form. Right? Same procedure. So find equation of plane passing through L1 and PQ, L2 and PQ. So what is L1? L1 is z axis. And what is PQ direction ratio? Is 1 1 minus 2, right? Sorry, minus 1 1 0. Minus 1 1. See, you have to take direction ratio of PQ, right? Don't confuse that with this, right? Okay. So this direction ratio is L2 direction ratio, right? The first half. But we need PQ direction ratio, right? Don't get confused. This is PQ direction ratio, minus 1 1 0. This direction ratio of PQ, right? This direction cosine of PQ. Okay. So it is x minus x1, y minus y1, z minus z1, a1, b1, c1, a2, b2, c2 is 0. So x1, y1, z1 all are 0. A1, b1, c1 is direction ratio of L1. This direction ratio of PQ, right? So expand this. So this will be minus x minus y is equal to 0. And similarly, find equation of plane passing through L2 and PQ. What is L2? We have converted the general form to symmetrical form. L2 is x minus 0 by 1, y plus 4 by 1, z minus 1 by minus 2. And we know PQ direction ratio is minus 1 1 0. So it is given by x minus x1, y minus y1, z minus z1, a1, b1, c1, a2, b2, c2 is equal to 0, x minus 0, y minus 4, c. It has to be y minus of minus 4, right? So I'm putting minus 4 here. Symmetrical form is x minus x1, y minus y1. But it is plus 4 here. I'm writing minus plus 4 as minus of minus 4. Then you will have y1 to be minus 4. So you will have plus 4, right? So just expand this. You will have one more equation of plane. Combine this and this, you will get the answer. So you will have x into 2, y plus 4 into minus 2. Check it once more, right? So combine this and this. So equation of PQ is minus x minus y is equal to 0. And it is equal to 2x plus 2y plus 2z plus 6 is equal to 0. Right, check once again. Check it once again. So in this class, what we did is we have first introduced uh, coplanar lines, and then we have introduced shortest distance between the two lines. So this is the procedure, right? If both in symmetrical form, do directly. If not, convert to symmetrical form and do the problem, right? So next class also we're going to continue some problems based on this only. So we'll see the next class. Thank you. All the best.